So for today's video, I'm going to teach you how to determine if a sequence is arithmetic or not. Okay, but before that, let me define to you what is arithmetic sequence. So when we say arithmetic sequence, it is a sequence of numbers such that the difference between the consecutive is constant. Okay, so for further explanation, let me give you some examples. So we have a sequence 2, 4, 6, 8, and so on. So when we say a sequence, it is a logical pattern or arrangement of values defined by a general term or n term. So each element in a sequence is what we call a term. So 2 is our first term, 4 is our second term, 6 is our third term, and then 8 is our fourth term. So, when we say a sequence shows a progression brought about by a common difference between the terms. So, when we say arithmetic sequence, it is a sequence whose succeeding terms are produced by constantly adding the same number. Okay, so the number added or subtracted number to each term is known as a common difference. Okay? So dapat pare-parehas ang common difference nila that makes it arithmetic sequence. Okay? So just to make it clear, you're just going to subtract the preceding terms to the previous term. So, 4 minus 2, and then 6 minus 4, and 8 minus 6. Okay, so let us get their difference. So, first, 4 minus 2, that is equal to 2. Or, just to prove if your answer is correct, you're just going to add the first term to the constant or your common difference. So 2 plus 2 is equal to 4. So this is our second term. So same process, 6 minus 4 or 4 plus 2, this is equal to 6. Okay, so same the common difference. Okay, so 8 minus 6, that is equal to 2. So since this sequence produce a constant number which is 2 or their common difference, they have the common difference. So this sequence is what we call an arithmetic sequence. Okay, another example. We have negative 4, 3, 10, and 17. So same process, 3 minus negative 4, 10 minus 3, and then 17 minus 10. So 3 minus negative 4, that is positive 7. Then 3 minus 10 minus 3, that is positive 7. Then 17 minus 10, same 7. So they have a common difference. So this sequence is what we call an arithmetic sequence. Okay? So now, an arithmetic sequence requires a common difference, right, between the terms. So given the following sequence, let us now identify their common difference to prove that the sequence forms an arithmetic sequence or not. Okay? So the given sequence can be identified as arithmetic or not by observing their common difference between the terms. So let us now examine the following. So we have the given 2, 7, 12, 17, 22, 27, and 32. Okay, so the difference with the succeeding terms will be as follows. So same process, 7 minus 2. 7 minus 2, that is equal to 5. And then for the third term, 12 minus 7 equal to 5. And then for the fourth term, 17 minus 12 equal to 5. And then 22 minus 17 equal to 5. And next is 27 minus 22 equal to 5. And then 32 minus 27, that is equal to 5 also. Okay, so the sequence has a 5 common difference, right? So therefore, it forms an arithmetic sequence. Okay? Next, we have the given 9, 14, 19, 25, 31, 38, and 45. Okay? So the difference with their succeeding terms will be as follows. So 14 minus 9 equal to 5. Next is 19 minus 14 equal to 5. Next is 25 minus 19 equal to 6. Next is 31 minus 25 equal to 6. And then 38 minus 31 equal to 7. Then 45 minus 38 is equal to 7. Okay, so the sequence has a common difference in the first two terms, right? These two terms. And then 6 in the next two terms and 7 in the last two terms. So since the sequence does not have a common difference between the terms, then it is not an arithmetic sequence. Understand? Okay, not an arithmetic sequence. Next example. We have the sequence 8, 6, 4, 2, 0, negative 2, negative 4, and negative 6. Okay, so the sequence shows a decreasing order of forms, right? So let us observe how it affects the difference between the succeeding terms. So same process, 6 minus 8, that is equal to negative 2. 4 minus 6 equal to negative 2. And then 2 minus 4, that is negative 2. Next, 0 minus 2, that is equal to negative 2. And then negative 2 minus 0, that is equal to negative 2, right? And next is negative 4 minus the previous term is negative 2, that is equal to negative 2. Next, lastly is we have the negative 6 minus negative 4, that is equal to negative 2. Okay, so they have the same common difference. So this sequence has a negative 2 common difference. So it is added constantly to the succeeding terms preceding a decreasing order of terms. So even so, the sequence follows the rule of an arithmetic progression. Therefore, it is an arithmetic sequence. Okay? Another problem. We have a sequence 3 and then 10 over 3, 11 over 3, 4, 13 over 3, and 14 over 3, and lastly is 5. Okay? So, the example involves a rational terms, right? So, let us now consider the following differences between the succeeding terms. So, same process, 10 over 3 minus 3, that is equal to 1/3, right? So, this whole number 3, automatic, there is a denominator 1, right? So, 10 times 1, and then 3 minus 3 times 3 is 9, so 10 minus 9, that is 1. So, 1/3. Okay? Next problem, 11 over 3 minus 10 minus, 10 divided by 3. So, here, just subtract the numerator. 11 minus 10, since they have a common denominator. Just subtract the common, their both numerators. So, 11 minus 10, that is equal to 1. So, that is 1/3. Okay? So, same process. 4 minus 11 over 3. So, 12 minus 11, that is 1. And then copy the denominator, 3. Okay, so the answer of this problem is 1/3. Next is 13 over 3 minus 4. So, denominator 1, 13 minus 3 times 4, that is 12. So, 13 minus 12, that is 1. And then denominator 3. So, the answer in this problem is 1/3 also. Next, we have 14 over 3 minus 13 over 3. So, same process. They have the common denominator 3. So, just subtract the both numerators. So, 14 minus 13, that is 1. And then copy the denominator. So, the answer is 1/3 also. And lastly, we have 5 minus 14 over 3. So, same process. in solving a fraction from whole number. So the value of this problem is 1/3 also. Okay, so the sequence has a 1/3 common difference, right? So therefore, it is an arithmetic sequence also. And lastly, we have the given x plus 1, 2x, 3x minus 1, and then 4x minus 2y. And lastly, we have the 5x minus 3y. So the example involves an algebraic expression as terms, right? So let us check if the expression produces a common difference. So same process, just subtract the second term to the first term. So we have 2x minus x plus 1y, that is equal to x minus y. Okay, so combining like terms, 2x minus x, that is 1x, right? So no need to put constant 1 here. There is automatic na meron ng constant 1 in each variable. So and then negative, positive, so kaya negative siya. So x minus y. Next is we have 3x minus y minus 2x, right? So combining like terms, 3x minus 2x, that is x, and then just copy negative y. Okay? Next problem, we have 4x minus 2x minus 3x minus y. Okay, so same process. 4x minus 3x, that is 1, right? So 1x. So x na lang siya. And then, negative 2 minus negative y, that is negative y. Okay, so the answer of this problem now here is x minus y also. Okay, so next is we have the 5x minus 3y is minus 4x minus 2y. So same process, 5x minus 4x, that is x only, then negative 3y minus 2y, that is y. So same answer, same common difference, right? X minus y. So the example requires a prior knowledge on the operation involving algebraic expressions. So the sequence has a common difference of x minus y, right? So therefore, it is an arithmetic sequence also. So that's all for today. So in problem number 1, the common difference is 5. So this sequence is an arithmetic sequence. For problem number 2, they have the common difference negative 2. So this is an arithmetic sequence also. And then for the problem number 3, they have no common difference, right? So this is not an example of an arithmetic sequence. And then the problem for number 4, they have a common difference 1/3. Um, so this sequence forms an arithmetic sequence. And lastly, for the last problem, their common difference is x minus 1. So this algebraic expression of this sequence is also an arithmetic sequence. Okay? I hope you all understand our lesson for today in determining a sequence if that is an arithmetic or not. Okay? Okay, so it's your turn. Try to solve this. Is it the sequence arithmetic or not? Okay? This is your assignment for today.